Okay, let's see if anyone's out there. Nobody as it stands. So we'll just wait a few seconds, maybe pop a message up. Refresh. Right, anyone out there? Yeah, but one person, two people. You just put your names in the chat box, as always, because remember that is your register. I'm just going to check on everyone's Dr. Frost work. Right, it's good to see people here. So we've got Kai-san. Just to make the point, your homework was set on Dr. Frost. You need to do it, okay? And I mean, it's the only person who's done it is Sheeing as it stands. So make sure you've done your Dr. Frost. It's due on Monday. Fine, have it done for Monday then. That's not a problem. Your name is Kelvin. Yes, Kelvin, amazing. Yeah, so yeah, make sure it's done by Monday then. I'm going to set another one for the Easter holiday as well, probably tomorrow. Okay? So we've got Kai-san, Kelvin, Reba, and we've got one mystery person. Nobody knows who that is yet. What we're going to do today is cover whatever things people are struggling with in terms of integration. So what I'm going to do is start putting down a list of topics that could be assessed for integration. I'm deliberately not doing differential equations because we're going to start that after Easter. So integration, you've got standard functions. And if you're following the book, I'm going to put the page number next to them so you can look these up if you're not sure what they are. So it's page 294. Sorry, I do apologize. F of ax plus b, which can be found on page 296. Identities, trig identities, on page 298. Then you've got reverse chain rule on 300. Substitution on 303. And parts 307. We're kind of running out of space there. And the last one, I'll just pop it here so you can see it easily, is partial fractions. So partial fracs. I'll move that down so you can see that a little bit better. Partial fractions on page 310. Which one of these do people need help with? So substitution is being requested. Okay. So some people have asked for substitution. So substitution is definitely one I'll cover. We're down on people at the moment, so we'll start in a couple of minutes on that. Anything else that people want to see in terms of integration, revision before? Because I'm going to do a test after Easter rather, on integration second year content. So this is your best time to just say, okay, I can't do this, I need some help with. All right, so this is going to be very much a teaching thing. Remember, we're going to change up a lot of stuff next term. It won't be quite so much like a YouTube video, blah 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 blah. We're going to do some other stuff too. What does the second last one say? Parts. Integration by parts. So substitution is the only one that's been requested so far. We are, at the moment, we only have, after Easter, we're going back to college now. You'd be lucky to see that college before September. I don't think we'll be back before September. Let's be real. We're just going to change up stuff. So just don't do the same thing every single day. For the first 2 or 3 weeks, I think it's a fair shout. You know, people are just learning how to use the stuff, getting all the kind of like methods organized. But we can be more adventurous after Easter. So I'm just going to wait on a few other people to show up. So we've got Kelvin, Reba, Mohammed, so that's Kai-san, obviously, and somebody else. Who's the somebody else? Right. Where are we going to do this test at home, obviously? I mean, I'm not coming to your house personally to invigilate, so, you know, I'm going to be quite creative on how we do this. But we've done mocks for year 13s, and they work moderately well. They're not going to be perfect, obviously. Be realistic about these things. You haven't done the register for Monday yet. That's fine. I'll sort that out. It's not a problem. Still waiting on a few more people. It's probably for the best I haven't done that register, because otherwise I'd have to mark quite a few absent. Let's see. Let's have a go at that now. See why that hasn't gone through. All right, so let's reconnect server. Thank you. All right, Sheen, we've got a 5th person and 6th person. Will we do the exam on Dr. Frost? I might. It's a thought. Farhan, you're here. Good. That's okay. This is worthwhile try. So yeah. So what I'm asking people to do, we've already got that. We want to see substitution again. What other forms of integration do we want to see again while I do the register? Well, if it lets me do the register, that is. Very frustrating, this thing gone. As we're down to 5 people, that's a bit worrying. There should be 8 total. So again, I've already had one request on a topic, which is integration by substitution. So you need to kind of pop up with what you want to see. I don't see you, man, here, no. So substitution is the only thing we're doing at the moment. And obviously that's not going to be an hour and a half's work. We're not going to be doing an hour and a half. Substitution, yeah. That's fine. I'm still waiting on this register to load up, so just be patient on this. I'll give you guys, well, basically I'll give until the register's kind of loaded up to people to show up. I will start teaching in about a minute or two, I think. It's the only sensible thing to do, otherwise you'll end up waiting for people that are not there. This takes forever. So substitution is the only one people are asking for. Fine, it'll be a nice short video then. Well, I'll put a few examples into kind of, make sure you get your fair share of teaching. Is there anything else other than substitution people want to see? So remember, I've got this. This is now like I've got evidence on this. If you fail the exam, like, you can't say I didn't say offer you. You know what I mean? So you got to be damn sure you understand these things. Ugh, it's taking forever to load up this thing. I don't know why it takes so very. Okay, here we go. Got register. Let's do register. As it stands, I've got 5 people. So let's see what's on the registers. Okay, I'm going to rub this one out, and we will start with substitution. And I'll show you some examples. Okay, so substitution works. So can I ask everyone to turn to page, let's find it. That's wonderful parts, isn't it? Page 306. So what we're looking for is page 306 in the Pure 2 textbook. Okay, I'll give you a few seconds to do that. I'm just going to run the register. Let's see if Kai-san's claim is true that we haven't done the register. No, he is wrong. We did do the register. Yeah, you are flat out wrong, sir. Okay, Iman hasn't showed up yet. Mohammed, that's Kai-san, so yep, he's in. Mirella, no show. Reba, yes. Kelvin, yes. Zarif, no. That's twice now. Excuse me. So what have we got here? So far, you missed Monday as well, I think. Kai-san in, obviously, we said that, and she in. Brilliant. Superb, yeah. Kai-san, you were wrong. And Farhan, where were you last time? Questions that stand before the house. Oops, daisy. There we go. You need some help to Dr. Judge for us. It's last updated 2603. That's your thingy. That's promo. No, that's your side, not my side, because I've just seen it. And it was marked in, so I don't know, and I'm not worried about it, quite frankly. You neither should you be, because you were marked in on both days. All right, so don't worry about that. So let's start with a very, very basic one. It's not 1/8. I mean, you can't get more friendly than that, can you? So you've got x root 1 plus x dx. And the thing to remember for substitution, and why have I lost people now I've done the register? Okay, tell you what I'm going to do. I'm going to ask you guys a question in about 5 minutes. Whoever doesn't respond to it, I'm just going to mark them absent. I mean, you guys need to realize I ain't playing any games here, right? If I'm bothered to do this, you guys shut up. Simple as. Right, so where were we? I'm going to do this guy, all right? The method to remember here is, first of all, if you're lucky enough that they give you a substitution, then generally you need to replace every vestige of the letter x with the substitution. Say I've got to replace, every time I see an x, I've got to replace it with a u. So here I've got u equals 1 plus x, so that's a pretty easy substitution. U goes in there, I can rearrange for that as well. So u minus 1 equals x, quite easily. But then I've got to deal with the dx as well, all right? Where are we? There we go. So we can say that if we differentiate u, you get du dx equals 1, because differential of x is just 1, differential of 1 doesn't exist, right? And that follows logically that dx du would also equal 1, because the reciprocal 1 is 1. So therefore we can write that dx is 1 du. Now they're not going to be that friendly, all right? But if for a very first example, that's not a bad shout. Okay, so we've now got u minus 1, that's x, times the square root of u, times 1 du. Obviously the 1 doesn't matter, so that becomes u to the 3/2 minus u to the half du. And you can just integrate that pretty easily, I hope. I'm just going to adjust the screen so it makes it a little easier to see what I've done there. It's a bit, so I know it's off on an angle. I don't know why that's being silly. Do this and then go like that. That's a bit better. Yeah, bear with me. Just try to be, yeah, I think you got most of that now, right? So that's a very, very simple example where you substitute in, you're given a substitution and you literally just plug it in and then you integrate. To be clear, that's not done till you finish doing the question. So that'll be u 2/5 u to the 5/2 minus, what would that be? 2/3 u to the 3/2 plus c. And then you'd have to substitute back in. Let's see if I can find a bit more space for you to see that. Whoa, that's not what I wanted. Okay, cool. I'll do it here. But the final answer will be 2/5 1 plus x to the 5/2 minus 2/3 1 plus x to the 3/2 plus c. So you do need to substitute the x back in. I know some of that's been clicked off, but you see how that works, right? Hopefully that's not particularly difficult for anyone. And in the spirit of not being particularly difficult, here's the question I'm going to ask you, and just to check that people are still watching this video. I'll rub this out now. The example I want you to do is, let's pick something reasonably friendly. How about c? Okay, and c is the integral of sine cubed x dx, and they're giving you the substitution u equals cos x. All right. So that's the one I want you to do. Again, I need to sort this camera. I do not know what this camera's playing today. Is it being straight? Right, okay, cool. Let's see if you can see that properly now. There you go, much better. So the integral of sine cubed x, it looks like a square for some reason. Sine cubed x dx using the substitution. I want you to try that for me and then type in the answer box what the solution is. Where did you get u3/2? Okay, when I did I had u minus 1. Yeah, got u minus 1, yeah, and that's a root u, yeah, so that's u minus 1 times u to the half. Don't worry, Farhan, because this explanation will give you a chance to catch up. Times this together, you're going to get u to the 1 times u to the half, which is u to the 3/2, minus u to the half. All right, that's all that was. So that was that intervening piece of work. So that's got nothing to do with this. That's just the piece of working out for Kai-san. That's the integral I want you to do. Does that now make sense? So pop a thing in the chat box to let me know whether that made sense to you now. You got it now, yeah? So it's turning something that was having square roots into quite a reasonable little polynomial, which you can handle, I hope, right? Any further questions on the example? You're still confused by which? What are you confused by? Remember, it's the chat box. I can't really see what you're confused by. What are you struggling with, Kelvin? Stuck with the one you just gave. What, the sine cubed one or the x root 1 plus x dx one? The one that I've just, is it the one I've just set? Because, okay, tell you what, I'm going to do this one now, right? And let's just walk through this. First of all, why is the substitution now? Because they said so. Yeah? Not always are you going to be given it. So, you know, sometimes you have to be creative with these things. But, right, so let's just do this. So u equals cos x, yes? Du dx equals, I hope everyone's happy with that. It's minus sine x, yeah? Remember your circles. So it follows that dx du is 1 over minus sine x. So kind of just write it like this, 1 minus sine x. So yeah. Is that okay? That's reasonable so far, right? So we know that dx, logically, is minus 1 over sine x du. Are you happy with that so far? Yeah? Hopefully. If I put this into there now, my integral has now become sine cubed x over sine x. I'm just going to put the minus sign here just to get rid of it. Du. And again, this is the downside of the plastic sheet thing. You don't really have enough space. I don't know why it writes at an angle. I really don't. So we're up to that point, right? You just excuse me a second. I'm just getting annoyed by this camera because it should be behaving better than it is. Right, so that's a bit better, right? So if I replace dx by du, this is what I get. That, of course, simplifies to minus, and then you've got a sine squared x du, right? That should be reasonably okay for everyone, right? But sine squared is just 1 minus cos squared. So that's literally just 1 minus cos squared du, yeah? All right. And then what's going to happen is this. Well, obviously, we can just put the minus sign back in, actually. I'll just deal with the minus sign now. So that's cos squared minus 1 du, yeah? Which is u squared minus 1 du. And I think you can handle that. That's quite an easy little integration to do. So that's the methodology behind doing this substitution, right? So what I'm going to ask you to do now is type in a chat box where and when you got confused, if you're still confused. And I suspect some of you might still be. So what did I do first? I differentiated, I've got dx, used it to simplify the integral, yeah? I mean, if at first glance, what you looks like the substitution isn't helping, always go to that du dx stage first and see when you simplify, does it make it better? All right? And then after that, obviously that's quite an easy one to integrate. If you finish it off, it's just going to be 1/3 u to the 3 minus u. So that's just going to be what then? 1/3 cos cubed u minus cos u. Sorry, cos x, sorry. Cos cubed x minus cos x. So that's your final answer there. All right? Plus c. So that would be my advice, and it's a good thing that we kind of picked that up quite early. That would be my advice for integration by substitution. If the substitution looks like it's not helping, or you can't see immediately how to, how to fix it, try doing the dx du bit first and see if it does anything to help you. And if it still doesn't, then you do have to start throwing punches and just carrying on, right? But you see how that worked quite nicely. So I'm going to give you about a minute or so to copy that all down, because that's a worthwhile example. And I'm going to give you a third example to try. All right? Remember, these are all question ones. They're pretty simple ones, actually. Because sometimes they don't give you substitutions, as you're about to find out. Okay, you've got about another 10, 15 seconds before I'm going to rub this all out. If you don't want me to rub it out straight away, can you drop a message in the answer box, or the chat box rather. So why do we use substitution? because it integrates it quite neatly. All right, it's another method. Remember I told you at the beginning when we were back in the classroom, those many, many years ago, differentiation and integration are different, because differentiation, you've only got 3 methods. You just stick to it, it's job done, right? Integration, you have to be really creative. You've got to use like whatever method works for you. So me teaching you substitution is giving you another method to being able to integrate stuff. All right? It's just another weapon in your armory. All right? That's why we're learning integration. That's why we use substitution. And why do we use substitution as a practical thing? It makes a hard integral and into something we can't integrate into something we can integrate. All right? Does that make sense? Right, cool. What I'm going to do is I'm now going to rub this out. Remember, you can always look back at this. The good thing about videos is you can always look back at them. I'm going to clear this off, and I'm going to ask you a question which is in a similar stuff. Can you use a different? Yes, if it works. Okay? Yes, if it works. But for today, if I set you a question, and I say it's substitution, for the sake of practicing substitution, substitute, all right? But then afterwards, if you have an exam and you want to use a different method and it's better, by all means do that. But for today, everything's substitution, because that's the one you asked for. So it's 1 plus sine x, my mistake. 1 plus sine x over cos x dx. And the substitution here is sine x, all right? So again, it's another one of these guys. Now you can see that perfectly. Now you can. Yeah, now you can. So it's another one of these where it might not be obvious why we've chosen sine x instead of cos x. Investigate and find out and put something in the answer box. If you are confused, do what you did before. Yeah? But this time, just say which you're confused by. All right? Always make it explicit. I don't understand the particular example I'm talking about, right? Because obviously I can't read your mind. Which is probably a good thing for both of us, really. Zarif again, absent. Morella again, absent. That is unfortunate. I'm going to have to do something about that over Easter. Be aware people are making decisions about people who are at risk. So as it stands, if Zarif doesn't show up, I'm going to have to put him on risk for further maths because he's missing lessons. So just be aware, like, attendance is super, super important. And for you guys, you've got an online record in the live chat of who showed up. It's not even so naughty. It'll be like, he won't be coming back next year. It won't be my choice either, because people will just look at that and say, well, why haven't you done something about it? Okay, cool. Let me set, so I'm going to set you your Easter homework now. Just be aware. And it's obviously, you've got 2 weeks to do that, so there's no rush. Integration. I'll make it substitution for obvious good reasons. Don't try and do it all at once. I mean, do one of them, then do the other. Number of questions, 10 questions. That's fine. So that's done. And there's no due date on it, so you've got till the end of Easter to do it. All right? So what you should be doing now is that integral over there. As soon as you've got a solution, let me know. And we'll do it together in about 3 or 4 minutes. So what else do we have to deal with here? Bounds. We need to do bounds. I'll need to cover that with you. There's a few bits and bobs to handle here. Oh, so frustrating. Right here. Let's see how people have done there. Right. It's amazing how that made you turn up. Fair warning, Zarif, right? I've noticed, as far as I'm concerned, if you're not on the chat at the beginning of the lesson, you are not here. I don't really care where sign-ins are, because like anyone can say signing, I'm here. But I need to see actual engagement in class. And we are doing the at-risk register this week. And I'm not impressed this week at all, I've got to say. If you've got any underlying reason why you've not been in lesson or you're not covering lesson, you can put that in the Microsoft chats. But as it stands, a bit of a sticky one. Quite a bit of a sticky one. Okay, now that's an honest answer. Your parents are ill. I hope they get better. But obviously, you need to let us know that. So obviously, then you don't get in trouble and there's no issue like that. All right. Take care of them. Wish them all the best. In these times, obviously, you have to be very careful and do look after them. But take care of yourself as well. I mean, if everyone in the house gets ill, you're going to all be in trouble. All right. So make sure you do look after yourself as well. All right. But do let the college know, because I'm sure other teachers will be worried as well, unless you made a habit of just missing mine. And as I said, we are being asked every week, who do you think is not showing up to classes? Who should we be thinking about? So who's committed and who's not, basically? Who's the kind? It's kind of, because we can't do the mock exams. We're going to be judging people on commitment more than anything else, rather than ability, which is a bit awkward. The ones who show up day in, day out, never miss anything, those people are, they're showing to us that, you know, even in coronavirus, they've got heart to work. And that's worth respect. So maybe they might be a bit dumb. I'm not saying any of you guys are dumb, but, you know, you think, well, you know what, give them another chance rather than give someone who's, you know, not showing anything. Anyways, have we got answers on this yet? We've got answers on this one. Are we stuck? Talk to me. Remember, I can't read your minds and I can't see your faces. So you're going to have to explain in the live chat how you're doing. You're stuck. Okay, cool. How about I'm giving a bit of a hint? We'll say, look, if u equals sine x, what's the differential of sine x? Du dx equals cos x. Yeah, you got something. Okay, cool. Tell you what, type it in the chat box, because there's no way I'm going to finish before you're going to type it in the chat box. So du dx equals cos x. So dx du equals 1 over cos x. And therefore dx equals 1 over cos x du. Yeah? So anyone arguing with that chain of mathematics, let me put that so you can see the whole chain of mathematics. All right? So Kai-san says that's what he got. 1 over cos x. Yeah, beautiful. Yeah, I agree with that. You are right. So if I now write this out as one big integral, that's 1 plus sine x over cos x, 1 over cos x du. Do you agree with that, sir? I hope you do, because if you do agree with me, you're right. Don't know what to do after. Here's the trick. If you times those two fractions together, obviously all you're going to get is 1 plus sine x. Well, that's okay. That's fine. I've got something besides this 1 plus u. What about the cos x? That's just going to become cos squared x, isn't it? Yeah? But I can write cos squared x as 1 minus sine squared x. So my integral now becomes 1 plus u, 1 minus u squared du. Now, can you post in the comments immediately if you don't understand that, what I did there? So I claim, once you get to here, you times them together. Obviously, 1 times anything is just the same thing. Cos times cos is cos squared. But then cos is 1 minus sine squared, isn't it? So that's why that's 1 minus u squared. Okay, I'm getting to that. Hold fire. You're not wrong, necessarily. I'm going to check that in a mo. So this is aimed at Kai-san, it's aimed at Kelvin. Do you understand up to this point? And Reba, if you've got the book, feel free to check the answer and check if you're right or not. It feels like you're right, but I'm not 1,000,000% sure on that, because I haven't finished it yet. Ooh, we've got 8 people now. More clear now, yeah? Okay, so let's finish this off then. Has everyone got what they need off this board? I'll give you about 40 seconds to copy. All right? We had 7 people, and then now we had 8 people, now we've got 7 people again. Sad. I mean, I'm going to give you about another 30 seconds to copy this, then I'm going to finish it from here. All right? And if you, Reba, if you can check your answer and pop in whether you got it right or not, that'd be super helpful. Otherwise, I'm just going to blast. I'm going to blast it anyway. You've got another 15 to 20 seconds copying. Just to remind everyone, your new Dr. Frost homework. Is it you? Oh, hell no, sir. Hell no. We'll do something quite clever in a minute, actually. If only for novelty value. But anyone who told you that that's how you integrate, please slap them upside the head. That's not going to work at all, all right? So just keep your eyes peeled in about 20 seconds, because I'm going to explain it. You don't know what to do after, what, this guy here? I don't blame you. That's what I'm going to show you next, all right? That's not a problem. You'll see it, and hopefully you'll get it. I'm just going to give 5 more seconds for people to copy. Lovely. Right, let's roll. here's how it works. And it's so beautifully simple when you see it. Because you've got 1 plus u, 1 minus u squared, agreed? You can factorize this by difference of 2 squares to write 1 plus u, 1 plus u, 1 minus u, right? Does that make sense to you guys? All I've done is difference of 2 squares. And I'm sure you can see the obvious at that point. The 1 plus u's are going to cancel. So you've got 1, so that shouldn't be a minus sign there, 1 over 1 minus u du, right? The only question I've got for, and it's for Rebut really more than anybody else, is where did your minus sign come from? Because when you integrate that, surely you just get ln, oh, I see why, because obviously, yeah, of course. I get it now. Ln, it'll be a minus ln because you want a minus sign on that. 1 minus u du, which is, if I minus ln, and what have you got on that? It's, u was what, sin x? Yeah. So 1 minus sin x plus c. You don't need the du there, obviously. It's actually just plus c. All right. So I'm hoping that's making some level of sense now. Just a little bit, pop that so you can see it a bit better. So yeah, what did we do? This is where we were on the last line. We did difference of 2 squares here. We cancelled our difference of 2 squares, and then we realized it was one of these integrals in this form, or nearly, of f dashed of x over f of x. Now, this is the key point. Yeah, thank you for asking that. Why is it minus? Brilliant. Because the rule is that this has to differentiate to make that, right? But that's a minus. The differential of minus u is minus 1, not plus 1. So what I'm basically doing is I'm saying that this is minus, this thing here is minus 1 over minus 1 over u. Because the 2 minuses cancel and it goes back to being plus again. So I turn this guy into a minus, but if I do that, I have to put a minus on the outside to balance it out and keep the math straight, keep these two equal to each other. So the integral of this would now be ln 1 minus u, but I'd still have the minus sign here, so it'd be minus ln 1 minus u. All right? Is that a satisfactory explanation of where the minus sign comes from? It's just the ones of those f dashed of x over f of x questions where it doesn't work straight and I have to make an adjustment, like times by 3 or divide by 5. Here I'm timesing by minus 1, all right? So pop it in the chat box if you don't like that, if you want a deeper explanation into why that's true. So I'm more than happy to provide. It's all integration, isn't it? Don't get it, okay. Can I ask you to copy out? Then I'm going to go back and explain that in loads of detail, all right? I hear that. Thank you for asking. Thank you for being honest about it. I just want to give everyone a minute just to copy this down because I need to rub it out to do your explanation, right? Thank you for being honest. Thank you. Super. That's fine. We'll deal with it. Copy it out for now, and then we're going to deal with that specific problem that you're saying here. All right? That's not an issue at all. Are we just doing substitution today? As far as I know, yeah, because and to be fair, during the substitution, we're covering quite a lot of other stuff. We're now covering f dashed of x over f of x. I mean, if people have got other things in integration they want to ask about, yeah, I'm more than happy to. I'm not going anywhere. I'm not running away. So as it stands, substitution. But if you've got something else in integration you don't like, once we've finished doing substitution, I'll say, okay, we finished substitution for today. If anyone got any more questions, just ask now, and then you can ask me then. And that way, it doesn't. Not everyone has to watch. Do you know what I mean? There's no one to waste everyone's time. Everyone basically said that we just want subs before you came in, anyways. All right, cool. And that's not a criticism. It's like, this is meant to be your time. All right, cool. So here's something else that's to do with integration. So this also kind of hits in that stuff. Suppose you had, the rule is, if you've got f dashed of x over f of x, the integral of that is ln f of x plus c. All right? And that's fine. We all know that rule. It's a familiar rule. Let's look at our specific example here. We had 1 over 1 minus u. Does this thing here differentiate to make that thing there? The answer is no. Because if you differentiate u, you'd get 1, and that's fine, but there's a minus sign on it. So the differential of this is actually minus 1. So I can't use this formula yet. I have to make an adjustment. I have to change something. All right? And the thing I change is I know for a fact that I'm allowed to mess with numbers on integrals. And you've seen me do this before. And the thing I'm going to do is I'm going to say, okay, let's times this guy by -1. So put a minus sign there. That's a minus sign. That's 1 minus u. Now I'm allowed to use the formula. And that's why there's a minus sign on the outside. I can see that Kai-san gets it. How about Farhan, Kelvin, and Zarif? Why don't you tell me if you get it or not? And if you don't worry. Yeah, we'll do a couple of examples of this. It's not an issue at all. Kelvin, you still don't get it? What's the problem? What part of it are you struggling with? Give me a little bit more explanation in the chat box, please, so I know exactly how to explain it. You need more examples. Okay, beautiful. We can do that. Let me give you one that hasn't got a negative sign in it. Yeah, 4 over 2x dx. This has got nothing to do with substitution, straight. Yeah. This would work if you differentiated 2x and you get 2. Yeah? Does that make sense? So this one, you can't do the method yet. Do you always times it by -1? No, I'm going to show you an example where you don't. If we differentiate 2x and you got 2, we could use the formula. So let's change the integral. And we're allowed to do this. Let's say that this integral is the same as that integral. Why is that true? Because 2 times 2 is 4, right? If you times this to that fraction, you'd get 4 over 2x. But now you could do the integral, because 2 over 2x is just going to be ln 2x. So you're going to get 2 ln 2x plus c. See how that works? Obviously, you can simplify that more. You can make 1 over x to get ln x. Another example for you. Let's go with 4x minus 3 over 5. Okay, because this is quite an awkward one. If you differentiate 4x, you get 4 in it. But that's 5. So we're going to do something about that. I need to multiply by some number. Yeah? So I'm going to go, okay, let's pretend this is 4x minus 3. Yeah? And pretend that is 4. What number turns me from 4 to 5? I need to times by 5 over 4, 1.25. And then I integrate that, I get 5 over 4 ln 4x minus 3. So basically, it's my way of turning something that I can't integrate using the rule into something I can integrate by using the rule. But whatever I do here to fix this, to make it work, I have to undo it on the outside. And before it was like, I needed to turn something negative that was positive. Yeah. So at times that made it a negative number. Yeah. So let's just look at that example once more. So you had 1 over 1 minus u. For this to work, I needed to turn that into a minus sign. Well, that's fine. I can do that. But as long as I undo it on the outside. All right. So the question that Farhan asked, do you always tell them about anything I need to? But as long as whatever I do here, I undo here. Okay. Yeah, of course. All the plus C stuff, just assume that. Yeah. No problem. Thank you. I'm glad everyone's happy with that. Okay. For me, on substitution, there's only one big thing left. It's an important one. So we're going to cover that now. If you've got hold of your textbook, or you can at least see one, if you look at question 2, you notice that you've got bounds to deal with. I'm going to do... Now, the ln is not inside the modulus sign there, yeah, Kelvin? It's the x that's on the modulus, all right? So you'd be writing, presumably, minus ln x plus c, for example, yeah? And to be fair, if you remember the original question, it had something to do with sign anyway, so that's not what we're looking at. Okay, so let's have a look at this guy. 5, 0 on x. Yeah, as soon as I finish this video, I'll do that. Okay, cool. As soon as I finish this video, in fact, as soon as I finish writing this example, I will email it to you again. All right, we'll do that. Because clearly you're having trouble with it. It's a bit annoying. Don't know why that would mess you up. Can I ask you though? As soon as you get it, save it onto whatever you've got so you never lose it again. All right. Okay, I'm going to do this example in a second. Let me just email Kai-san with the book. Message. Let's see if I can find it myself first. Kai-san. Yep, there we go. Got you. That was Caitlin. Caitlin was doing GCSE. Browse computer. Should have it somewhere. Is it my textbooks folder? Yeah, it is. What are you up to? Open. Is that the second year book? Yeah, don't be like that. Yes, got it. Right, it's just sending to you in the next few seconds, all right? So hopefully you're going to get that. Yeah, Kaisen, I've sent that now. Hopefully you get that. Oh, you need it as well? Okay. My dudes, I sent this out how many times now? Right, fine. Let me send it again. Right, as soon as you get this email, save it onto your desktop or whatever you're using, your tablet, put it in like your ebook reader. I don't care what you do with it, just don't lose the bloody thing, all right? And if anyone asks me after today, you know what? I'm just going to tell them. Ugh. I'll cough on them. Right, so who else needs this? That's, yeah, so Kais, okay, cool. I want to forward to everybody. So Rebot, Xiying. Who else wanted it? Let's just check. Xiying Wang. Who else needs it? Kelvin. Okay, fair shout for you. I take the point on that. In your case, you didn't lose it. Kelvin. I'm going to send it out to everyone. That way it saves us some pain. Reebok, Yang, Kelvin, Marilla, even though she's not in. Actually, no, Marilla, she doesn't deserve it. She can catch me up if she wants anything. Who else needs stuff? Zarif, obviously, because he asked. Farha, I'll pop you in as well. You probably do have it because you haven't asked for anything. Not Farhana, that's another person entirely. 1, 2, 3, 4, 5. Who else is in the class? Kelvin, I've done. Zarif, Farhan. Iman, I know, has it, so there's no point wasting time with him. I think that's everyone then. Okay, so again, that's gone out to everyone now. All right. So what I'm going to do now, while that book's coming through to you, no problem, is walk you through this example here. And the only difference is you're going to have to substitute the bounds as well. All right. So as before, u equals x plus 4, du dx. I mean, you start getting into the rhythm of these things, and you can go straight away that dx is just 1 du. I hope anyways, that's pretty simple. So you've now got, and it's very, very similar to the other one, you've got u minus 4 times u to the half. And this is the important bit. This is the new thing, right? You've got to put the bounds in there as well. So if your x equals 0, 0 plus 4 is 4. So that's 4, and that's 9. All right? So that's your new integral, du. Obviously, we can finish the integral. I'm going to do that. It's not a particularly difficult one. So 9 to 4, u to the 3 halves. Sorry, move the camera there. Minus 4u to the half du. All right? So what has changed in this new question? Almost nothing, other than you've got to remember to mess with the bounds as well. Because these bounds are written in terms of x here, they need to be written in terms of u, and then you could substitute the numbers. Now, once you've finished, so we integrate this guy, what do we get? I'll pop it here. That's going to be, where did I get 9 and 4? Thank you for asking. I put 5 into this, so 5 add 4 is 9. I put 0 into that, 0 add 4 is 4. Okay, so I substitute my upper and lower bounds into u to get new bounds in terms of u. All right, so hopefully that answers that nicely for I'll just give myself a little bit more space here. Anything written on there, no, can have all the way up to there. Okay, cool. So what do I do now? Again, it's going to be 2/5. So we've done a very, very similar question to this already, 5 halves. You don't know how to integrate your bounds. Good, you're about to find out. Well, it's not good, but I'm not sure you have to do it now. So integrate this as normal. So that's up to 3 halves. U to the power 3 halves. And then you'd be times it by, so it'd be 8/3, wouldn't it? It's a bit ugly, but there we go. Yeah, 2/3. Yeah. Cool. No plus C. So that's the first thing to know about integrating with bounds. No plus C. And what you do is you just literally put 9 into this and then put 4 into this. All right. So I'm going to write it out here. Actually, no, I'll put it up even further. Should have just enough space to do this from here, anyways. So you do 2/5, and remember you've got a calculator to handle this. To be fair, you've got a calculator to handle all of this. So 9. Sorry, I'm being very stupid. 2/5 times 9 to the power of 5/2 minus 8/3. Yes, you can. Unless they ask you to do it by hand, of course, in which case you should know how to do it, all right? And then if you're allowed to use a calculator, of course, you use the calculator if you've got any kind of choice. So all I've done is substitute 9 into all of this, and I'm now going to take away the same thing, but just with 4 substituted into all of this. And for this, you should be using the calculator, this part. Once you've written it out, feel free to blast it with the calculator, and that's absolutely fine. That's what they're there for, all right? So one bracket with just 9 substituted in, one bracket with 4 substituted in, take away this bracket from that bracket. Game over, all right? You can use, now, where can you use a calculator? I mean, you can use a calculator from here. Your calculator will do it straight from there. You don't need to mess around with this. But you should at least know how to do this, all right? You should at least know how to do that. And I mean, if you never need to use it in your life, great, okay? Good. You use the calculator every single time, that's superb, all right? The way they get around this, and I think I've said to you this before, is they'll do things like have lines that dip under the x-axis, so you have to calculate it in 2 or 3 bits, and you'd have to draw the picture, etc. All right? But that's how you integrate with bounds, and the only difference is you're going to have to substitute your bounds into U. What I'm going to say as of now is, if you've got further questions, hang around. So will I, don't worry. Okay? If you think you're ready to take on exercise 11E, do so. Okay, so 11E. And you remember, you've already done some of this at some point. Sorry, you can't even see that. I do apologize. 11E. So if you want to go now, you're free to go. All right? If you've got more questions about integration, I'm going to be here for a while. All right? I'll answer your questions on integration. Everyone's got books now, so we're sorted. After Easter, things are going to change up a bit. As I said, we're going to be doing a lot more creative stuff, like Kahoots, things like that. All right? So that's that. I mean, take care of yourselves over Easter. If anyone needs anything, drop me a message on Microsoft Teams or email is probably the fastest way to get hold of me. If you're in, like, for example, like Zarif's situation, talk to me. That's kind of handy. Because obviously we don't know what's going on in your life. If we know, for example, your parents are ill, we're going to behave a lot more like a human being than if you're bunking and smoking weed. So the more you let us know about stuff, the more we can help you, if that makes sense. All right? Do take care of yourselves, all right? If anyone needs any further help, hang around, ask me questions in the chat box. But otherwise, you're free to go. And I wish you the best of Easters, given this strange world we're living in. So all I'm doing is now waiting on the live chat for any questions. And I'll wait for a few minutes, don't worry. I'm just going to run away. I'll tell you what. Let's see if anything's popped up. All right, Zara, if you take care as well, yeah? Why did you say that? I mean, if your mum's still there, I'm going to say this on absolute record. I have never heard of Kai-san ever taking a drug of any type in my life. All right? It was a joke. Okay? Don't worry. You're absolutely fine. Kai-san is a good student. Has turned up to every single one of my online lessons. Perfect attendance. I'm not even just saying that. It's actually true. If you look at the registers, it's absolutely true. Right, yep, same to you, Zarif. Shing, you look after yourself, all right? Take care, all right? Don't take any unnecessary risks going out, okay? I want you guys, like, coming through this. And be aware that this isn't going to end anytime soon. I reckon we're going to be doing this until, I don't think we're going to be back till September, I'll be honest with you. I mean, God knows what we're going to do after that. I don't know if any of you guys have thought about how are we going to pick up the pieces after all this. I don't know. Don't think anyone knows, to be honest. We'll see. I mean, kind of. In any case, I am done here. So if you've got any questions, now's the time to ask. Anything you can't do. How do I know? Very good question. How do I know? I mean, just looking at the kind of trends, it looks like we're still about 2 weeks away from, you know, the worst of this. I think you'll start seeing people loosening some of the social distancing stuff soonish, like within about another month. I think we're gonna have another month of, like, you know, lockdown. But then another month takes us to what, May? And you finish in June anyways. So they might say, let's not take the risk. I have not heard anyone say anything other than you'll be incredibly lucky to be back before September. All right. The graph is exponential. It is for now. And that's one of the things we're going to cover actually is something that we're going to do in stats is it's exponential for now. When does it turn? The integration on that's quite difficult. It's a further maths topic I'll cover with you. Anyone else got any particular questions? I'm happy to hang around here. There's no problem. It's my lesson time, so it's all good, all well and good. And you're free to go though, all right? You're free to go. This is not like you haven't got, you know, there's no point just sitting here for no reason. I'll hang around here for another 2 or 3 minutes just to make sure that everyone's got their chance to ask any questions. Yeah, you learn exponentially, yeah, but integrating it's a bit more interesting. Because one of the graphs is, if you look at cumulative death rates, that's not a, well, it resembles an exponential, but the integral you want is the third one. Yeah, you need help with Dr. Frost. Let's see. Okay, I'm going to go on to Dr. Frost now. I've set that right. Good. Okay, cool. Bear with me just a moment. I'm just checking our class. So by class, further maths. Quick class select. Get all further. Okay, cool. So you've had a few. Whoa. Easy. Yeah, cool. Right, let's go back. Bear with me just a sec. So I'm not going to give a due date on this. Immediately. Someone's bossing at me. I don't know why. You forgot the password. Yeah, exactly. That's what I'm going to do. I'm going to sort your password out. Just bear with me 10 secs. I'll message you back what your password is. Not that there's any great secret. It's just going to be password. Integration. Subs. Set task. Why you always do that? It's annoying. Set files. FM. Okay. Set. Okay. For God's sake, what are you up to? It's very stupid what they're playing. Boom. Select all. Okay. Right, that should now work, right? Set task. Yes. Yes. Okay, cool. Let's find your managed classes. Further maths. Okay. Kelvin. Change password. Kelvin, your password is password. All right. No caps. Your password is password. Will the email be? Yeah, it's the no, it's the student.ac.uk. It's this one. Let me just type it in the chat box. It's this guy here. Sorry, student@candy.ac.uk. And your password is password. All right, no caps. Don't worry, no one can steal your password. Even if they do, what can they do? Do your maths for you? You'd be grateful. All right, so yeah, that guy. Okay. Unless anyone else has got any further questions, and I'll wait a few seconds for that to be able to answer that. That's your lot, I think, and that's your lot this side of Easter. As long as we all survive, I'll see you after Easter, I guess. Right, okay, I think that'll be that. I'll give it another 10 seconds in a minute. Take care, Kelvin. Look after yourself. Have a lovely Easter as best as you can in these situations. Take care. End stream? Yep. That's end stream.